Sister and brother surfers of the binary ocean, what's up? In this video we are going to add immediate mode. So if we look at the Write Yourself a Fourth website here, we finished our compile mode, and the next one is implement a way to compile immediate words. And if we look at, there's another page here, finding words in Forth on forth.com. It's got the word immediate makes a word immediate. It is used in the form, so it comes right after, a compiled word is defined, and it is executed right after the compilation of the definition. Not going to be too crazy to implement. The first thing we want to do is go down to the very bottom of our program, and we're going to create another function. This one's going to be called last compiled word, and you can probably see where we're going with this now. We are going to get the most recently, the last word on the compiled words string, the very end words. And since we're just appending to that string, the last word there is going to be the most recently added word. And immediate means run the most recently added word, basically, at least for this version of Forth. Now we're going to create a variable full definition. That's going to be a string subsequence. Initialize that as an empty string. Oops. And then we're going to create a variable just called definition. Once again, another string subsequence. Once again, initialized with an empty string. And one final variable here, word name string. That's just going to be an actual string. And once again, just an empty string for now. And now we got some logic here. If let word index, once again, look at these indexes. We've used this pattern several times in this program. Last index, so we haven't used the last index function yet. That just gets the last instance of whatever this character is. So we're giving it the colon. It's going to get the very last instance in the string, which is this compiled word string. And then it's going to return the index of that. And then within this, so if we get a word index, if we find it, which we're going to, if there's any compiled word at all, right, then we're going to assign a value to full definition. That value is going to be compiled words word index to the end, okay? And then we need another if let word index equal full definition dot end index of colon. So now we're getting the index after the colon, basically, of our full definition. And so that's going to give us, the first part of our word. And say we had that, say we had that, or rather in our string, in our compiled word string, it would look like this. So at this point, we're just going to be getting that. And then we got to shrink that down so that we just get that. And the way we're going to do that is, so with our full definition, we're going to go definition equals full definition word index to the end, and then let definition array, and we're just using this array just as kind of an easy way to solve the problem of the fact that we have multiple parts here. We have Bob 2020 plus 1, 2, 3, 4. And so if we break this into an array that's separated based on these spaces, so then it's, then all we have to do is say, okay, and then just, if we want the name of the word, the last compiled word, all we have to do is get the first index of the array. And that's what we're going to do here. So components separated by space. It's another pattern we've used at least once in this program. Word name string equals definition array index 0. So that'll be the first index, which would be that Bob in our, if our last compiled word was Bob. And then before we end our function, we want to return word name string. So that's a good function there. Now let's go back up in our code to our process input function. And we're just going to add under, let's go right above compiler here. We're just going to add another else if. This one's going to be else if input equals immediate. Then we want to let word to run equal last compiled word. So this is a call to our function that we just created. And the string, the word name that gets passed from this function, is going to go to this word to run variable or constant. And then let run word, and then let's just copy. We're just going to do some copying and pasting here. So we want to run our run word function again. So just copy this and paste it right there. And then let me just make sure, I think, yeah, that should be good. That's exactly what we want. So return to, and then we'll just fix this. There we go. Okay, and then there's one little issue I wanted to fix too this is actually from our last video, and I noticed, so in GForth, let me show you this. If we define a word and then we redefine it, so we wanted that to be 2030, it says redefined and then the name of the word. So I thought, oh, that's kind of nice, maybe we'll just add that. It's really easy to add. If we go down to our function, the cleared compiled word function, and we can just add a print statement in here. And let's, right after this, if it finds the word, then we know it's going to be clearing it out since it found it. So we'll just say print redefined and word. Let's run our fourth, test things out. So initialization of word to run. Uh-oh, got a weird warning here. Mutable was never used. Word to run was never used. Oh, probably need to do something about that. Let's go back up. What do we got? If immediate, let word to run equal, and then, okay, so we want to put word to run is what we want to pass into our run word function. All right, cool. The warning might have saved us a little bit of searching there. Okay, so let me just do I'm just going to redefine Bob here, and you can see, so now it says redefined Bob, which is cool. I like that. And then since we put periods, I wonder if we should put a period after that, since I put period after okay and after compiled there. Let me do that real quick. Let me just scroll down. Word plus period. I don't know. I mean, that's stupid. That's just silliness to, fuss over that or anything. That doesn't really matter. But and actually, GForth does not do that. But I don't know. Maybe it makes CruxForce stand out a little bit. I guess, right? 3030 plus redefine Bob. Okay, and then so that's that, and then let's test our last compiled word. So let's do Bill 50 minus 30 immediate. Why didn't it do that? Didn't run it. Okay, we're missing something here because yeah, it didn't run it. Let's try this. Okay, what did I do wrong? Oh, no. I think this might be it. We need a space there. Let's try that. Wow, that one little space. Ha, there it is. One stupid little space makes all that difference. Isn't that crazy? Programming. Computers, I'll tell you what. Immediate. Now you'll see if we run immediate again, it's always going to go for whatever our most recently compiled word is, but I think that's fine. I don't think that's an issue because you know, immediate's always going to just be used after, you know, when the user wants to run the most recently compiled word, so it makes sense. So that's it. In the next video, we are going to fix a little, well, maybe not so little bug, or not even a bug. We're going to basically add a feature that I noticed wasn't happening, and I just took it for granted, I guess, that it would work, and it wasn't. It's not. So we're going to fix that, and that is, let me just show you. If we got Bob, and then let's say we have Bill, 30 plus, and then Norbert. I don't know why I actually give my words like names of human beings, but so now if we wanted to run Bill and Bob within our Norbert word, we call Norbert, yeah, that doesn't work. We should get some, you know, these values on the stack, or not, it's not working. So we're going to fix that in the next video. Thanks for watching this one, and stay tuned for more. Peace out.